Quick revision video on AS organic synthesis practical skills. So in the video I'm going to cover Quickfit apparatus, distillation, reflux and the purification of organic liquids. So we'll start with some essential Quickfit apparatus. So you can see I've numbered them up 1 through to 9, so we'll just go through the names and their functions. So number 1 is a pear-shaped flask, and we use that for heating liquids. Number 2 is basically just a glass stopper. Number 3 is a round bottomed flask, and that's also used for heating. Number 4 is what we call a still head, and that's used to connect the next piece of apparatus, the Liebig condenser, to the flask. And you'll see all this connected on the next slide. Number 6 is called a receiver adapter, and that goes at the end of the Liebig condenser. Number 7 is a separating funnel, so we use that in the purification process. Number 8 is what we call a screw top adapter, and basically it allows us to connect a thermometer to the top of the still head, and again you're going to see that in a moment. And number 9 is a Quickfit conical flask, and that's used for collection of liquids. So the next thing we'll look at is the apparatus and setup for distillation. So there's a diagram showing the setup for distillation. So I'm just going to talk through this and explain how the process works. So your liquid sample would be sitting in the pear-shaped flask I've got here. Remember, you can use pear-shaped or round bottom flask for heating. And that's sitting in, I've got this in a water bath. Not a good idea to use naked flames with organic liquids because a lot of them are flammable. So typically we'd use a water bath, or you could use an electric heating mantle. Because we're heating this liquid up and we want them to evaporate, it's a good idea to put anti-bumping granules in, and that gives you controlled evaporation or controlled boiling inside your flask. So number 1 is obviously a pear-shaped or round bottom flask. Number 2 is your still head. Remember, that connects the flask to the condenser. Number 3 is either a stopper. If you're not bothered about controlling the temperature, if you don't need to control the temperature, you could just have a stopper there, or you might want to use a thermometer to control the temperature, and that enables a closed system. Otherwise your vapour is just going to go straight out the top there. Number 4 is the condenser, and just important point to note here, water always goes in at the bottom of a condenser and it comes out at the top. So you've got 2 glass tubes essentially. You've got this inner tube that your vapour will start to travel down here and condense inside here, because we've got cold water running through the outside glass tube. Number 5 is your receiver adapter, so you're just connecting the bottom part of the condenser to your collection vessel. So I've got a test tube in this diagram. You could use a conical flask. And often it's a good idea to collect your distillate. That's what we call the product from distillation. It's a good idea to collect your distillate over very cold water or iced water, just to prevent any evaporation from taking place, because organic liquids tend to be quite volatile. So we'll look at the apparatus and setup for reflux now. So very much simpler diagram here. So we've got a heat source at the bottom. Remember, that can either be a water bath or an electric heating mantle. Don't forget your anti-bumping granules, so those little grains of, we use aluminium oxide, and they would be put in with your organic liquid to prevent it from boiling uncontrollably, which is known as bumping. So number 1, pear-shaped or round bottom flask, and number 2 is your condenser. Water goes in at the bottom. And notice that we don't use a stopper in the reflux apparatus, because your sample or the product that you're trying to make will evaporate, travel up the condenser, but long before it gets to the top it just condenses back down and goes back into your flask. So there's no need for a stopper. So if we move on now to the apparatus and procedure for purifying an organic liquid containing water. So often when you make an organic liquid, there might be small traces of water present that you want out of the sample. So this is how you would do that. So we take the separating funnel and we add the organic product to the separating funnel, and remember there's tiny traces of water in here and we want rid of those. Next thing we do is we add distilled water and we're going to allow those layers to separate. And an easy way to tell which is the aqueous layer is it's the one that gets bigger. So the way I've drawn this one is I've got my organic layer on the top and I've got a large aqueous layer. So all the water that was in that organic layer would tend to go into there now. So we've managed to separate the water from the organic layer. It's gone into there now. And so the next thing we do is we're going to allow the aqueous layer to run out. Remember, I had the aqueous layer on the bottom. If it was the organic layer on the bottom, you would just allow that to run out. Next thing we would do is we'd collect the organic layer in something like a conical flask. So you can see I've got that there now. And just in case there's any tiny small traces of water still in your sample, you add what's called a drying agent. So you can see those little circles that have appeared in the organic layer in the conical flask. They represent the drying agent, and a couple of examples for you are anhydrous calcium chloride or anhydrous magnesium sulfate. And now finally all we need to do is we need to get the organic layer on its own and leave the solid behind. So you can either filter it or a process known as decanting, where you literally just pour off the liquid and leave the solid behind. And so you're going to be left with your original conical flask with the drying agent in, and you've got your pure organic substance in there now. Final thing to look at is the procedure for purifying an organic liquid that contains another organic liquid. So sometimes when you make organic liquids, you get another organic liquid distilling over with what you want if the boiling points are quite similar. So the way to deal with that is you basically distill it again. So that process is called redistillation, and this time you're very careful with your temperature, and it's controlled closely to make sure that only your desired product is distilled across.